Kia ora, Year 12. This video is a stats question from Specimen paper 6, which is the Statistics 2 paper. And this is another question on sums and differences of random variables. It's worth 10 marks out of 50. So this is an important topic, and one of the things that's good in this question is it gets you thinking about the difference between linear combinations of random variables and just sums of separate random variables. So we're going to read through the question first before we do it. This first one is about, well, the whole question is about these two kinds of light bulbs. So we've got long live light bulbs and inner low light bulbs, and we're given their normal distributions, and we're told that they're independent. And that's important for being able to use our results. So that's this one here is the long live ones, and the mean of 2,800 is the inner low ones. The first thing we have to do is to find the probability that the total of the lifetimes of 5 randomly chosen long live bulbs is less than 5,200 hours. So when you're thinking about that question, that is not the same as working with 5L, right? It's not a linear combination question. It's what you can think of as an L1 plus L2 and so on up to L5. And that affects how we find the mean and the variance. Now, in the second question, we have to find the probability that the lifetime of a randomly chosen inner low bulb is at least 3 times that of a randomly chosen long live bulb. So this is one where I'm going to set up a difference between two things and work with some linear combinations. So let's do question 1 first. Well, we've got the long live bulbs have got a distribution like this. So the mean is 1,020 and the variance is 45 squared, and that works out to be 2,025. So what we need to find before we can standardize and use our normal table is the expected value and the variance for 5 bulbs. So here, you don't have to write all of this out, but this will help you when you're learning it. We can add up the separate means, which is the same as just timesing the mean by 5. Right? So 5 times 1,020, which gives us 5,100. And then for the variances, we can also add up the separate variances. Plus the variance of L5. So we're getting 5 variances added up, and that gives us 5 times 45 squared, which is 10,125. Now the mistake that people make here is to do this, so don't do this. But if we go var of 5L, that's 25 times the var of L, right? But that's for a different situation. That's for what we need in part B. So now we're ready to go. What we're looking at is the probability that the total of the lifetimes is less than 5,200 hours. So we want the probability of this, and we're standardizing. So we take our value that we're interested in, 5,200, we subtract off the mean, and we divide by the standard deviation. We figure out what that number is, and we turn to our Z table. So we get Z is less than 0.99, what have I done here? 0.9938. So if you look now at your normal table, which is on this page, you can see that that's in the form that we want, right? So we want the probability that we're below a positive value. So in here, we have to go to 0.99, and then I can only go to one more decimal place. So I'm going to go to 0.994. And I need to take this value and add on those 10 little points. Right, so this is equal to phi of 0.9938 or 994, and that's 0.8389. Now the way I usually do this is just to write the extra points down there, 0.8399. So to 3 significant figures, my answer is 0.840. So that's the first bit done. Right, let's go up and have a look at the second part of the question. Okay, find the probability that the life of a randomly chosen inner low bulb is at least 3 times that of a long live bulb. So I'm going to start by setting up some kind of new random variable. And in the school exam, you didn't do the set up set step very well, but I think it makes it easier to structure your answer and show you're working. So the expected value of this thing is going to be equal to this. And when you work that through, you get 2800 minus 3 times 1020, which is negative 260. Now we can get the variance of it. So the variance of it is going to be the variance of E plus 9 times the variance of L. That works out to be 52 squared plus 9 times 45 squared, giving me 20,929. So just notice the way I've defined it is the inner low one minus 3 times the long whatever they are. And this is a negative number, and you've got to watch that in the next step, because we want the probability that that thing, D, is strictly positive. So we standardise by subtracting off the mean, and the mean is a negative number. And then what am I doing? Okay, bad working. Where are we? It's probably that Z, sorry guys, a bit tired, so probably that Z is greater than 0 minus negative 260 over the square root of this. And you just have to be fluent at using your normal tables to go from here. So this is equal to probably that Z is greater than 1.797. Sketch your picture and you'll see that that's going to be equal to 1 minus phi of 1.797. We can hop over to the tables and let's have a look again. 1.797 is where? Well, there's 1.7. Whoops, 1.7 here, 1.79, and then we want the add-on here. Right, so we've got 0.9, oh, wrong pen, 0.9633 plus 6 gives me 0.9639. So my final answer is going to be 0.0361. All right, so hopefully by now these questions are starting to feel very comfortable. You'll find them in lots of past papers. So what you might want to do is find a whole bunch of questions that are a bit the same but a bit different and practice them in a row. And then just go back to the section in the textbook to go over the sums and differences of linear combinations if you need to. Thanks for watching.